Hello students, you are once again welcome to today's class, and it's still a continuation of Unit 5, Work, Energy and Force. And in today's lesson, we are going to learn about simple machines. We all know what machines are. We all have ever used machines. What are machines? Or what are simple machines? Alright, without wasting time, we can say that simple machines, these are simple devices that affect the force or efforts needed to do a certain amount of work. Simple machines are simple devices that are used or that affects the force or efforts needed to do a certain amount of work. We can as well say, we have a question down here, what is a simple machine? One can also say that a simple machine is an object or a device that facilitates work by changing the magnitude or the direction of force. Let's continue and learn more about simple machines. Yes, as we have already seen what simple machines are, let's continue. Please, I want you to take note. Simple machines cannot change the amount of work done. No. But they can reduce the effort needed to do the work. I will give you an example. If let's say you are doing work on a computer, it can be one computer to do work for 10 people. So the effort is reduced, the amount of work is constant. So please take note. Simple machines cannot change the amount of work. If the amount of work is 300 joules, it remains 300 joules. Maybe this 300 joules is supposed to be done by 300 people. Now, instead of using the 300 people, you can use only one machine to do that work. Okay, that's why we are saying that simple machines cannot change the amount of work, but they can reduce the effort needed to do the work. Groups of simple machines. Simple machines are grouped into 5. The rivers, wheels and axle, the pulley, inclined plane, inclined pulleys, wedges and screws. So those are the 5 categories of simple machines. I've told you, take note of this. 1. Simple machines cannot change the amount of work done, but they can reduce the effort needed to do the work. That's 1. 2, I have told you that simple machines are grouped into 5. And these 5 groups are the rivers, 2, wheels and axles, 3, pulleys, 4, inclined pulleys, and 5 are called wedges and screws. We shall see all this as we go ahead. Alright, we have said there are 5 groups of simple machines, and the first one was the rivers. Now let's look at one at a time. What are rivers? Rivers are beams or rigged objects that turns about a fixed pivot or fulcrum. A river is a beam or rigged object that turns about a fixed pivot or fulcrum. The pivot is just fixed, but the other part of it, the beams can turn around. It's used to lift or move heavy objects. Levers are used to lift or move heavy objects. Now, let's see how does a river work? How does it work? It works on this principle of movement or force. How does a river work? When a force is applied to it at one end, it causes the river to rotate about its fulcrum, to move a load at its other end. A good example is a seesaw, as we shall see ahead. A river works when a force is applied to a river at one end. It causes the river to rotate about its fulcrum, to move a rod at its other end. Please take note. Rivers work on the principle of movement of force. They work on the principle of movement of force. So it's the force that determines how the fulcrum should be turned around or should be turned about. Okay, let's continue. Now let's see the groups of rivers. Rivers are grouped into three classes, and these classes are: 1. First class river, the second class river, and the third class river. Now the question is, how are we able to tell that this machine is under first class, this one is under second class, and this one is under third class? It all depends on the position of the load, the fulcrum, and the effort. Okay? Note, all the three classes depend on the position of the load. Load in this case is the same as the work, the fulcrum, and the effort. Where are these three positioned? Actually, what is in the middle of that machine determines the class of the river. Alright, as I told you, there are three classes: the first class river, the second class river, and the third class river. And don't forget, we said that what determines the machine either to be called first class, second class, or third class is the position of the effort, the fulcrum, or call it pivot, and the load. Okay? The most important is the position of the fulcrum. For instance, when we look at the first class river, this is when the fulcrum is between the effort and the rod. E, F, L. E is effort, F is fulcrum, or call it pivot, and then L. L is the load, or call it work. Examples of such devices or machines, we can have the scissors, paras, the seesaw, the hammers. Let's look at the scissors. This is a scissor. So you can see this is the effort. What effort have you applied to do the work? So the effort is right here, and in the middle is a fixed point. A fixed point which is called the fulcrum or the pivot. And then we have the load. Let's look at the pairs. We have the fulcrum still, it's in the middle. The load and then the efforts. Seesaw. When we look at the seesaw, in the middle is a fulcrum and there are two boys seated on the seesaw. The other side we have a lighter boy, and maybe this boy is 10 kilograms. Then on the other side we have a boy who is heavier, and maybe this boy is 45 kilograms. So what will happen? Where there is, it is going to incline. Where the heavy boy is seated is going to go down, and the lighter boy will go up. So it is rotating around the fulcrum. Let's look at the hammers. The same story. When you look at the hammer, this hammer is plucking out a nail from a piece of wood. So where the piece of wood is the rod. So this is the rod. Fulcrum is still fixed, and then the effort applied. So the effort is applied to the fulcrum in order to pull out the nail. So that is first class river. If I ask you to give me examples of devices under the first class river, one, talk about the scissors, you can talk about the seesaw, you can talk about the hammer, you can talk about the pairs. Question 1. Why is a seesaw called a first class river? Who can give us the answer? Why is a seesaw, a hammer, a scissor called the first class river? Why is it so? It's very simple, because the fulcrum is between the effort and the rod. As simple as that. Once the fulcrum is between, then such a machine is regarded as first class river. Let's continue.